All right, this is the review part 1 for the Unit 1 test. I told you guys that the ones we didn't get to in class, since we were still catching up from previous notes, I would do in a video, so here that video is for part 1. So we're trying to find the exact radian measures for the following angles. So we did a part in class, so we're looking at 620 degrees. To convert that into radians, we need to multiply it by something that will cancel out degrees and also help us, remember, have that pi. We learned that, remember, 2 pi was the equivalent of 360 degrees. So if you think about changing something over, you can either divide either way, but if you divide one way, you get pi over 180. And if you divide the other way, you get 180 over pi. So those are our two ratios we use for conversion. You know which one to use based on what you're trying to cancel out, degrees in the bottom or radians in the bottom, the pi in the bottom. So since we want to cancel out degrees, we're doing pi over 180. Now, because they both end in a 0, you can cancel that out. So this is really 62 pi over 18. And then those are both at least divisible by 2. So we're going to start there and divide this by 2. That would give me 31 pi. Divide 18 by 2 and you get 9, and that has nothing else in common, so that would be my radian measure. For number 2, we're going to look at part A this time. We're going to be converting that to degrees. So same idea, we're going to multiply this one though by 180 over pi. So negative 15 pi over 4 times 180 degrees over pi. The pi's will cancel out. We asked the question, does 180 divide by 4? Because if it does, that'll reduce that. And it gives us 45. So that makes that 45. And then we're going to be, now you don't have a calculator on the test, I will say that. So you would have to do that by long division. So remember, 4 into 180, 4 goes into 18 4 times. Bring down the 2 left over, bring down the 0, 4 goes into that 5 times. So you will have to do that by hand. And then we have to do 45 times 15. So that's 25, carry that, so that's 22, 0 placeholder, and then 5 and 4. So that ends up being 675 degrees. Okay, we did 3 in class. For 4, part B, we're looking at trying to transform the left side into the right side, but remember, we don't do anything between the two sides. We just take this and try to change it so that it ends up being a 1. Now, we had some Pythagorean identities that look like they might be involved here because you have the squared parts. So this is sine squared theta plus cosine squared theta equals 1. We also know if we divide all of those by sine, that gives me 1 plus cosine divided by sine would be cotangent, and 1 divided by sine would be cosecant squared theta. If we divide them all by cosine, that would give me tangent squared theta plus 1 equals secant squared theta. Now notice, these are both variations of those. Tangent squared plus 1 is secant, so we can go ahead and write that 1 minus sine squared theta times 1 plus tan squared theta equals, so we know the second one is secant squared, which I didn't write my C, theta. The first one is 1 minus sine, which means they actually solved this top equation for cosine squared. So that's cosine squared theta. And then secant, remember, is the reciprocal of cosine. So this is cosine squared theta times 1 over cosine squared theta. And since 1 on top and 1 on bottom, they cancel out, which leaves me with just the 1. So we did verify that that identity is true. The left side was then transformed into the right side. Okay, for this next group, you're looking at the special triangles and 0 and, of course, 90 degrees. So essentially quad 1 of our unit circle. So remember that we have the point 1, 0, and then up to 0, 1. And then we have this part of our circle. And remember, we had 3 special angles that we looked at. What happens if this was 30 degrees, if it was 45 degrees, and finally if it was 60 degrees. And I know those are rough sketches. And then we found out these points, remember, by looking at the special triangles. So a 30, 60, 90, just trying to rough sketch this. In a 30, 60, 90. If your hypotenuse or radius is 1, 30 is always half of that, and then 60 you can find by Pythagorean theorem, but it always ends up being square root of 3 over 2. And then in a 45, 45, 90, you get that if the radius is 1, these two have to match, so x squared plus x squared equals 1 squared. When you go to solve that, you'll get square root of 2 over 2 for both of the sides if you rationalize. So we know that those are kind of our points. Remember, that's square root of 2 over 2, square root of 2 over 2. Because remember, a triangle centered and standard position, the point connected to that is always the x length, which is one of the legs, and the y length, which is the other leg. So it's really telling us the legs of the triangle. So for the 30-degree one, notice that you have an x value. That's the way this is drawn. That's an x value of square root of 3 over 2, which means the y value is 1/2. And then for 60, it's reversed. So it's 1/2 comma square root of 3 over 2. You just flip which one is at the origin. So that pretty much tells us almost everything we need to get, remember, sine and cosine right away, because sine and cosine are related to this ordered pair on the unit circle. So remember, the cosine theta is the first part, and the sine theta is the second part when you're in a unit circle. So that means we can fill out this whole part right here just based off our ordered pairs. So sine of 0 degrees is the y value here, so that's 0. Cosine of 0 degrees would be 1. Sine of 30 degrees would be 1/2. Cosine of 30 degrees is the square root of 3 over 2. Sine of 45 degrees is square root of 2 over 2, and that's the same thing for cosine. 60 degrees is sine is square root of 3 over 2, and its cosine is 1/2. And at 90, the sine is 1 and the cosine is 0. Notice the sine one is increasing from 0 to 90 degrees, where the cosine one is decreasing. That's because as we move around the circle, our y value is getting taller, but our x length is getting shorter because we're moving closer and closer to the origin again. Now, tangent we find by just doing sine over cosine. So 0 over 1 is 0. 1/2 over square root of 3 over 2. Remember, you would flip that, multiply the reciprocal. That's 1 over square root of 3, which we rationalize to square root of 3 over 3. So square root of 3 over 3 is the answer for that one. For this one, you put the same thing over itself, so that's 1. On this case, you get square root of 3 over 2 over 1/2, which means that it ends up being square root of 3 over 1. And 1 divided by 0 is undefined. Now, if you have all of those, so remember this is the answer for this one, you just flip them for their reciprocals. So you've pretty much done half of the work already. So if you flip a 0, that makes it undefined. So remember, cosecant is the reciprocal of sine. So this is now undefined. And tangent is cotangent's reciprocal, so this is undefined. This 0 over here, that's cosine, which the secant would be the undefined. And anytime you have undefined, that then becomes 0 when you flip it the other way. So this one, tangent would then become, cotangent would be okay, because it would be 0 over 1 again. Okay, so this secant is just 1 over 1. So if we flip it, it's still going to be 1. 1/2 would flip and make 2. This would be 2 over the square root of 3, which I would rationalize and get 2 square root of 3 over 3. This was 1 over square root of 3, so if we flip it, it's square root of 3 over 1. That's easier than having to rationalize it again. These would become 2 over the square root of 2, which if we rationalize is just square root of 2, because you get 2 square root of 2 over 2, so the 2's on the outside cancel. So this one's also square root of 2. 1 flipped would just be 1. This would be the 2 square root of 3 over 3 again. This would be a 2 over 1. This is 1 over square root of 3, which is square root of 3 over 3. And the final one is if you flip 1, you get 1. Now, it is weird to see it in this chart format because we're used to writing it long ways, but this is essentially just find sine, cosine, and tangent for each of these, and then flip them to get the other pieces, the reciprocals. Okay, for 6, we're verifying this identity. This had to do with the formulas for negatives, which we said that the only two even functions in this are cosine and secant. and that the odd functions were everything else. So tangent, cotangent, sine, and cosecant. Okay, what that means is when you plug a negative into an even function, it comes out just as the same as the positive x plugged in. So negative x gives us, f of negative x is the same as f of x. If you have an odd function, f of negative x becomes the opposite of that y value. So it becomes negative overall of f of x. So the reason that's useful is that just tells us if these are going to end up being positive or negative signs here. So cosecant is odd. So if we write cosecant of negative x times cosine of negative x, because we're trying to transform this into the negative cotangent of x. The cosecant one is negative because it's an odd function, so negative cosecant of x. Cosine is an even function, so it just becomes cosine of x. Cosecant, remember, is 1 over sine, so negative 1 over sine x. It's not negative sine, it's the reciprocal of sine, times cosine of x, which makes this negative cosine of x over sine of x, and that is negative cotangent. So that does make it equal the other side. Okay. All right, so looking at 7, we're supposed to be finding the exact values of the following. To do this, especially if these are 30, 60, and 45 degree angles, you just need to know your unit circle. And that's the point of these, is that there shouldn't be a lot of work involved, maybe drawing where the quadrant is so you know where the sine is. Like 150 degrees is in quad 2. And that leaves you 30 degrees here. So this is referencing a 30, 60, 90. And remember, in a 30, 60, 90, half is across from 30, square root of 3 over 2 is across from 60, and the radius, or the hypotenuse, is 1. But you have to be careful with signs. In a quad 2, you have negative x values, positive y values, and the radius is always positive. So when we ask what's the sine of this, you have to remember which one is sine. Sine is the y value, so this would just be 1/2. Tangent of 315, so I'm going to draw a little picture for each of these. So this was A. And now if you have your unit circle filled in, remember, because I said I'm going to give you some time to fill that in, you shouldn't have to draw all these pictures. But 315 is all the way in quad 4. And it gives you a 45 degree reference angle. So that means that's a 45, 45, 90. So this is a square root of 2 over 2, a negative square root of 2 over 2, because that is the negative y's in this quadrant, and a 1. And we're doing tangent. So tangent, remember, is opposite over adjacent. So that would be negative square root of 2 over 2 over square root of 2 over 2. So that ends up being negative 1. For cosecant of 3 pi over 2, first of all, you have to locate 3 pi over 2. That is on one of the quadrants. So I'm going to do, sorry, this was actually C. We did B in class. So for D, I may need to add myself some room to draw. We're going to be doing 3 pi over 2, which is down, it's the negative y-axis. Let me fix this real quick. Okay, so for D, you are down here at 3 pi over 2. Now that has an ordered pair of 0, comma, negative 1, because we're on the unit circle, which means the radius is also 1. And cosecant is the reciprocal of sine. So 1 over sine of 3 pi over 2 will also give us our answer if we wanted to use that. And remember, sine is the y value here. So 1 over negative 1. So that would just be negative 1. All right, let's talk about secant of 90 degrees. 90 degrees is up here. It's the top part of the y-axis. That's the point 0, 1. Secant is, remember, 1 over cosine of 90 degrees. But here, unfortunately, cosine is 0. So 1 over 0 is undefined. And then we have cotangent of pi. So pi is over here, remember, from 0 to 180. And that would be the ordered pair -1, 0. Cotangent is always the x value divided by the y value, because tangent is y divided by x. So x divided by y is also -1 but divided by 0, so that's undefined. So those last two are both undefined. Okay, so this leads us into number 8, which all of these are, they're all negative directions, so we have to draw our pictures a little bit differently. So for A, -2 pi over 3. Okay, so remember, the way I get my pi over 3s is I actually count by pi over 6. And remember, that's 30-degree intervals. So every quadrant is a 30, 60, 90. So this would be -1 pi over 3, -2 pi over 3. So right here is -2 pi over 3. Now that was 2 clicks, so that actually means that's 60 degrees. So for 60 degrees, I'm going to write that out to the side. We're talking about a 30, 60, 90 triangle. So that means this is the 30. So that makes this 1/2. This is square root of 3 over 2. And this is the 1. And remember, we are in a quad 4, so that's a negative y value. Now sine, remember, if you're here, it's just when you have the unit circle, remember, sine is just the y point. So that's why it's going to be negative square root of 3 over 2. Cosine of -225. So we have to figure out where that would be on a picture. So for B, let's draw a picture real quick. I'm going to make sure I go ahead and give myself plenty of room before we get too far into these. And no. All right, so for B part, -225 degrees. So that's more than moving 180 degrees past. So we've already gone 180. Let's see what the difference is there. So 180 and 225, we need to go 45 more degrees. So we're actually, if we go this way, that's -180, and then we go an extra 45. So it's going to be a 45, 45, 90 triangle in quad 2. That's square root of 2 over 2, square root of 2 over 2, and a 1. And in quad 2, x's are negative. And that is going to affect us because cosine is related to, when you're in the unit circle, it's the x value. So it's negative square root of 2 over 2. You can find that by doing adjacent over height too. You don't have to just grab it, but it is the point value. Tangent of -7 pi over 6. Okay, so 6 over 6 is pi, so I already know that this is going more than 180. So here is 180 or pi, and then that would be one more pi over 6 up. And remember, pi over 6 is a 30-degree reference angle. So this is 30, 60, 90 again, but this time it's 1/2 for y, square root of 3 over 2 for the x, and a 1, and this is still negative because we're in quad 2. So we're looking for tangent here, so that's going to be opposite. Remember, 30 is our reference angle, so opposite over adjacent. So that is 1/2 over negative square root of 3 over 2 times by the reciprocal. We get -1 over square root of 3. And if we rationalize that, that would be negative square root of 3 over 3. Okay, let's look at D. So D is not quite 180, so we have to figure out, first of all, it's more than 90, so we did move past quad 4 since we're moving this direction. So that's 90, so we've moved somewhere over to here. If you subtract 180 and 135, you'll see that that's a 45-degree angle. So again, 45, 45, 90. So this is a negative x, square root of 2 over 2, a negative y value since we're in quad 3, square root of 2, and then the radius is 1. So cosecant, remember, is 1 over sine of negative 135 degrees. And sine here is the y value. So this is 1 over negative square root of 2 over 2, which means it's the reciprocal of that. Multiply top and bottom by square root of 2. You're going to get negative 2 square root of 2 over 2, or just negative square root of 2. So this one is just negative square root of 2. All right, secant of negative 11 pi over 6. That's almost 2 pi, because 2 pi would be 12 pi over 6. So this one, by the way, was D. So for E, we're at pretty much almost all the way. So this is the negative 11 pi over 6. We have pi over 6 left over, which is 30 degrees. So this is 30, 60, 90. That's 1/2 square root of 3 over 2 and 1. And like I said, you don't have to draw the triangles each time. It's just very visual, so I find it helpful. If we're doing secant, we're doing 1 over cosine of that. And cosine is x values. So this is 1 over the square root of 3 over 2. And that would be 2 over the square root of 3, or 2 square root of 3 over 3. And then finally, the cotangent of negative 300 degrees. That is all the way over here with a leaving of 60. And that makes this a 30, 60, 90. So this is 1/2 square root of 3 over 2 and 1. And we're doing cotangent, which is x over y. So remember, in the unit circle, you just grab those values. So that's 1/2 over the square root of 3 over 2. We've done this guy before. You end up getting 1 over square root of 3, which rationalizes to square root of 3 over 3. So you don't have to draw the triangles each time. You can use your unit circle, but sometimes if you're just stuck, drawing the picture will help. Okay, the last two for part 1, we need to do the graph of sine x and then the graph of cosine x, just the basic sine and cosine, no transformations. So we learned that if you know your 5 main points, you can graph the one cycle or period of sine, and then you just repeat it onto the group that they need. So the points that we care about the most are 0, pi over 2. This is if you have traditional sine or cosine, not any transformations. Pi, 3 pi over 2, and 2 pi. Now obviously we'll extend that to 4 pi and negative 2 pi in just a second. And we care about a height of 1 and negative 1 on our unit circle. So sine of 0 is 0, sine of pi over 2 is positive 1, sine of pi is 0, sine of 3 pi over 2 is negative 1, and sine of 2 pi is 0. That is our 5 main points. Now those are found, remember, from looking at the y values on each point around the unit circle, or actually thinking about those triangles. So then we want to repeat this pattern. So notice they were going up by pi over 2. So if you add another pi over 2, because remember 2 pi, if you write it over 2, that would be 4 pi over 2. So if we add another pi over 2, that would make this 5 pi over 2. Then we would have 6 pi over 2, which is just 3 pi, 7 pi over 2, and then 8 pi over 2, which is 4 pi. So that pattern is going to repeat between those points, and you draw obviously better than I do probably. And then we need to go back to negative 2 pi as well. So negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. This time you're finishing this cycle, so it's going down and then up, then down. Now remember, sine goes on forever, so this is just a piece of it, so I'm going to put those arrows on there. So there's my 5 key points. Now if I wanted to list them, because they do say the words list, that means I usually write them as a chart, or I write them on the graph. So this is 0, 0. This is pi over 2, 1. This is pi, 0. This is 3 pi over 2, negative 1, and 2 pi, 0. Those are the 5 main ones of the original cycle. And then for cosine, because that's the end of part 1, remember it starts a little bit differently, because at 0, the cosine value is actually 1. So you start up first. But the cycle keeps going up and down just like it does with the sine. So let's get our 5 main points first. So 0, 1. Then we go down to the x-axis, so pi over 2, comma 0. Then we continue down to -1, so pi, -1. Then it's back up to 0 for y value. And then finally at 2 pi, back up at 1. So we graph those points, and we get kind of it almost looks like a valley. And then we repeat that. So I'm not going to list all the points out, but you do your same values just like I did, spread out. And you show that it goes in the same pattern. Except I think I didn't go far enough. I'm not scaling mine too well because this should have gone up again. And then on the other side, you would do the same thing. So let's put those in between points in there. There we go. There we go. And then on this side, we have negative pi over 2, negative pi, 3 pi over 2, negative 2 pi. So we go down, down, up, up. So the cycle still repeats. And that's it for the part 1 video.